The broadcast is now starting. All attendees are in listen-only mode.
24. Ooh, we're Good morning. This is David Peary. We'll start in just a few minutes. Good morning. My name is David Peary. Welcome to our webinar on attics and walls, what's new in the 2019 Title 24 Energy Code. We are recording this session. Everyone is on mute and will be on mute throughout the duration of the webinar, so feel free to type in the Q&A box with GoToWebinar. My colleague Matt Christie will do his best to respond right there in the chat box, and then at the end we'll also address some verbally. I am a project manager at TRC. What is the WISE program? It stands for the Workforce Instructions for Standards and Efficiency. The mission is to educate the home building industry on solutions for meeting high performance envelope requirements, particularly walls and attics. It's sponsored by the CEC, managed by Consul, and TRC, where I work, we're a subcontractor for Consul. The timeline of this program, it started in 2016 and ends at the end of this year. And we provide training like today's webinar. Our agenda will quickly go over Title 24, what it's all about, what qualifies as a high performance attic or wall, the climate zone requirements, the differences between the 16 and 2019 codes, some best practices, some challenges that builders have faced, and resources, and then we'll do some Q&A at the end. This is a screenshot of the California Energy Commission's website. I just did an internet search for 2019 Title 24, and you'll see kind of I believe this is a newly redesigned website. And if you scroll down, you'll see a few different sections there. Expand them, and there are the PDFs of the 2019 code. Some of them are specific to residential, some are specific to commercial, some cover both. There's 5 main documents that apply to the residential standards. Some of them are quite lengthy, in excess of 500 pages. I think it's fair to say that no one, including myself, is an expert in every single piece of this code. So we're just going to address a small sliver of it, walls and attics. There's another source, Energy Code ACE, which has a browsable version of the code, and it's very convenient. I typically use this when I'm looking for something myself. And the 2019 code was just added to Energy Code ACE in the searchable format fairly recently. Previously, only the 2016 code was there. So what qualifies as a high performance attic? The code refers to several different options. There's option A, B, and C. For shorthand, we'll refer to them as HBA A, B, and C. A would be for above deck insulation, HBA-B for below deck insulation, and HBA-C for ducts and conditioned space. There's also, those 3 are prescriptive options in the code. There's also an unvented attic, typically referred to as UVA. It's not a prescriptive option, but it would meet the requirements for what we refer to as a high performance attic. As a reminder for the code, the energy code, there are mandatory measures, and as it implies, those are mandatory. There's no way to get around those things. Then there's prescriptive compliance, and that's what we're going to look at today. for the most part, but as soon as you deviate from that prescriptive option, you're basically going to the performance path, which allows a little bit of flexibility. But when you deviate from those prescriptive options, you're typically penalized if you're doing something that's less stringent. Here's a diagram of above deck insulation. You'll see in blue, there is rigid foam insulation above the roof deck. You'll also notice that there's an airspace between the tile roof and the top of the roof deck. That rigid foam insulation is sandwiched between two pieces of OSB plywood. You'll see in this case, there is still loose fill attic insulation above the ceiling deck. So we're talking both the roof deck and the ceiling deck. This is also above deck insulation, but without an airspace. And an airspace is beneficial. We typically want to see that. The code requires a little bit more insulation if you don't have that airspace. HPA-B with an airspace, this would be, I'm down in Southern California, and this is what we see most commonly. You'll see the blown insulation above the ceiling deck as is typical, and then you have probably batt insulation underneath the roof deck, and then your OSB, and then your tile roof with an airspace. You also see in green there's a baffle there. In my diagram here we have a soffit vent, and you still want to be able to vent the attic, so you don't want that insulation on the roof deck to come all the way down to that crevice where there is a vent. If you're using venting penetrations in the roof deck, similarly, you don't want to cover that up with batt insulation. Same diagram here, but without the airspace. Here's a photo of some batt insulation looking up underneath the roof deck. And here is HVAC, ducts in conditioned space. This shows ducts in a pop-up ceiling truss, sometimes referred to as a doghouse. Ducts in conditioned space could also be fulfilled by placing ducts in a drop ceiling, the interstitial space between floors, an insulated crawl space, a basement, and a fully insulated and conditioned attic, or exposed in the living space. Ducts in an unvented or sealed attic do not count as a ducts in conditioned space. Instead, that's its own category, which we'll discuss on our next slide, an unvented attic. So this is if you're going to follow a performance approach. This is not a prescriptive option in the code. And it essentially moves the thermal boundary from the ceiling to the roof deck. You're probably looking at about R38 below the roof deck. Again, this is not the same as ducts in conditioned space, but performance modeling can show similar results depending on the R value and other aspects of the home design. Okay, let's take a look at the different climate zone requirements. Here is table 150.1-A from the main Title 24 code. You probably can't read that, so let's zoom in a little bit. This table actually covers a few pages, and this first one is just on the roof, ceilings, and walls. I'll zoom in a little bit closer even yet, and you'll see way up at the top here, we're looking at single-family homes, which is primarily what we're addressing today. Over on the left-hand side, we have roofs and ceilings, and option B and option C. You saw my note earlier that option A has been removed. That's the above deck insulation as a prescriptive option. So we see the different climate zones up across the top. I'm only showing climate zones 1 through 9 right now. You'll see the below deck insulation, whether it's required or not for that climate zone if you're going with option B, the ceiling insulation, and a radiant barrier. You'll notice that there's an NR not required for climate zones. What do we have here? 1 through 3 and 5 through 7. You do put on a radiant barrier in those situations typically, but it's worth noting that without that insulation below the roof deck, it's not really a high performance attic. It's not required for that climate zone per this prescriptive option. The 2016 table looked very similar, but you'll see that there is that option A. I mentioned that has been removed primarily because no one was doing it. The option B or C or something else has been much more popular. It's not to say you can't do option A, it's just not a prescriptive option in the code. You would be doing it in your performance method. Also note that there is table 151-B, and that is for multifamily, low-rise multifamily. So if you're working on multifamily properties, make sure you're looking at the multifamily table. What qualifies as a high-performance wall? Okay, in the code, the 2019 code, it gives a few examples. What we're looking for is what is the overall U factor of the wall assembly. So here's some examples. The first one, we have a 2x4 stud, and these are all 16-inch on center, as is common. A cavity insulation of R15, which is high density batt. And then we have exterior insulation, rigid foam of R4. And so you add those up, the assembly would give you a U factor of 0.065. You'll see we have some examples with 2x6 walls, various types of insulation, and what those what things add up to. And this example table is all 16 inches on center. Now there's another document, the joint appendices, there's several of them, and the fourth one has table 4.3.1, and this is kind of a little cheat sheet. And if we zoom in here, what we'll see is lots of different options that the math has been done for you as to what that U value is. And what I've highlighted here, and this is probably a lot to absorb, so let's walk through this a little bit. Up at top, you'll see that we have spacing 16 inches on center and several examples. Down towards the bottom, we have 24 inches on center. The first column is what the cavity insulation is between your studs. Your frame sizing, 2x4, 2x6, we even have some 2x8 examples. And then for your the columns on the far right are the rated R value of continuous insulation. So that would be your rigid foam insulation that you're probably putting on the outside of the wall, but there's numerous different assemblies that would work. At any rate, I've highlighted two different numbers. So if we had a 2x6, 16 inches on center with R19, that's the green box there up at top, and used R4, for the continuous insulation on the outside, that would give me an assembly U value of 0.055. Now what I'm highlighting here is if you were to go from 16 inches on center to 24 inches on center, that eliminates some of those thermal bridges that the studs cause. And so by moving those studs out, going from 16 to 24 inches, you can actually get a little bit bump, probably about 0.2002 difference in U value by going to a 24 inches on center. And that might be worthwhile for builders to consider because in many cases, the 2x4 walls that we've been building with in California for decades now very frequently are not going to cut it. We're probably looking at 2x6 walls starting January 1st when the 2019 code goes into effect. So if builders are spending a little bit more money for the 2x6 walls, 2x6 studs, maybe worth considering spacing them out. Here's an example of a 2x6 wall. I know the details are not hard to see, but I think what you might be able to pick out is there's multiple layers to this wall, and the point is we're looking at the full assembly. Here's a 2x4 example. So from the gypsum board, the stud, all the different insulation and vapor barriers, those all go into the assembly U factor. There are also options to do away with your stick frame construction completely and look at structurally insulated panels or insulated concrete forms. There's probably a few other options out there for building your homes, but these provide very good U values as well. Okay, just like we did for attics, let's look at the climate zone requirements for walls. Here's that same table. We're just going to focus a little bit lower down on the table and really just at one line in particular. And there it is. Let's actually zoom in just a little bit more. So for a high performance wall, it's defined as what its U value is. And you'll see that in the 2019 code for almost all climate zones, it's a U factor of 0.048. The two exceptions being climate zone 6 and climate zone 7. I'm down in climate zone 7 right now, where it's 0.065. So to compare from 2016 to 2019, back in 2016, the table looked exactly the same, just different U value. It was 0.051. It's become more stringent in 2019 to go to 0.048. That's what we just saw on the table. And the climate zone 6 and 7, those two exceptions actually didn't change at all. So those remain at 0.065. Here's that table from 2016, distant memory in just a few months. Okay, that's the bulk of the big takeaways as to what things are, but there's some other changes that we want to talk about that kind of relate to walls. One is that starting January 1st, we're moving away from TDV as the main metric to EDR. TDV is time dependent valuation and EDR is the energy design rating. And I have a next slide, we'll go into a little bit more detail there. QII, quality insulation installation, is a prescriptive requirement in the base model. It's not mandatory, but if you're an energy consultant or working in the modeling software, you'll see that if you deselect QII, you'll be penalized heavily. And so for most people, QII is more or less required going forward. We also know that solar is required on every home. And up through the 2016 code, we saw that these high performance walls and attics were maybe a little less stringent, but they were there in the code as a prescriptive option. But what a lot of builders would do is work around that by just slapping on photovoltaics on the roof. But that is no longer really allowed as we move to an EDR rating and look at it from a few different perspectives. There's also a battery storage credit that can come into play. And then the high performance walls and attics we just talked about. Again, the above deck is no longer an option, and we have more stringent R and U values for both up in the attic and on the walls. Okay, this is a screenshot from some modeling software to emphasize that in 2019 we'll really be focusing on the energy design rating, and we look at it in two different ways. We really want to differentiate between energy efficiency measures and renewable energy measures, which is typically photovoltaics. So you have two different scores. You have your efficiency EDR plus your renewable EDR and your total EDR. And you want to meet the required values for each of those as a base model would set those. I think by now we all know that photovoltaics are required, so slapping those on to get away from some good envelope design is no longer an option. There's also a community solar option, so if the instead of putting solar panels on each and every house, if in a close by location, you could do a community solar farm. That I don't believe I've seen any yet, but is an option. And then batteries also. This is something that gives you some credit in the model by reducing your PV size. Let's see, grab my note here. There is an efficiency EDR performance credit with batteries that can be traded off against high performance attics or walls or whatever other efficiency measures. Its maximum value is tied to the difference between the 2016 and 2019 high performance attics and wall measures for that climate zone. Okay, let's dive back into some best practices. Here we have a photo of a radiant barrier underneath the roof deck, and someone's decided to go with high performance attic option B, which is the below deck insulation. In this case, it looks like just regular batt insulation. But that radiant barrier is not going to work. Radiant barriers cannot be sandwiched between those two pieces. Radiant barriers require an airspace. And if you ever want to have fun, if you want to stump the expert, ask them how a radiant barrier works. I've observed a lot of people don't understand how that radiant barrier works. It's a shiny material and it certainly reflects light, but down there in the attic, we don't have the sun shining. What we're doing is preventing the thermal radiation from transferring from that roof deck down into the attic. But it requires an airspace. And so by putting batt insulation right underneath it, it totally eliminates any value there. So if you're doing below deck insulation, no radiant barrier required under that roof deck. Gable ends. In this picture here, we see that the gable end has been insulated just as the roof deck has been insulated, but typically that insulation, the batt insulation on that gable end is not required. However, a radiant barrier is required. Here I have on the left-hand side a building inspector energy inspection checklist from Energy Code ACE. And it mentions for the insulation to look at form ENV03, which is over to the right, which I downloaded from the CEC's website. And you can see right there, radiant barrier. Radiant barrier must be installed on all vertical surfaces in the attic, including gable ends. We had a lot of confusion on some projects through utility programs on exactly that question. So I'm pointing that out right here. Here in the Residential Alternative Calculation Method Reference Manual, on page 14, we talk about quality insulation installation. And it says that the question that's come up is, does QII apply to the attics? And here we go. Credit for verified QII applies to ceilings and attics. So yes, with this QII, the rules apply not just for your walls, but up there in the attic as well. And throughout these various Title 24 documents, you'll find a little tidbits of information on QII, on other wall and attic requirements throughout. And so one point I want to make here as we look at some of these is information is sprinkled throughout the various documents. Here we look at the reference appendices, and there's a whole section on quality insulation installation procedures. I thought that is something, if you're not familiar with QII, go directly to the source and see what it's all about right here. One section I'm highlighted here, batt supported with cabling, tension rods, or other methods supporting the batt from below shall be supported at intervals less than or equal to 16 inches. So QII not only applies to the whole building, but there are also some specific QII instructions as it pertains to putting insulation underneath a roof deck on a, it's not a vertical surface here. So QII gives some of those guidance. some common challenges. Several of the major utilities in California ran a master builder program to help get over the learning curve. So we have some results from that. Some of the adoption barriers would be lot size. If we're going to 2x6 walls from 2x4, either you're you have to accommodate for those few inches. The framing differences, if you're going to go from 16 to 24 inches. Cost is obviously a big barrier. Learning curve and materials, decision-making process. I think in many ways, 10 years ago, maybe the energy model for a project was done at the very end. So the building was all designed and you put it into an energy model and got your results. Now that we're looking at not being able to fix any deficiencies by throwing on photovoltaics or just increasing the efficiency of your HVAC or domestic hot water, but really looking at that envelope as being a critical piece of the design, that's something that would be hard to undo at the very end if your model doesn't work out. So getting the decision makers in with the energy modeler and other stakeholders early on in the process, always better. Sequencing for attics, my small little pictures there are below deck insulation with some venting. But the challenge that I want to point out here is the sequencing out on site. Typically, your roofer is going to be making penetrations in the roof deck to put in his or her vents, but where before they'd cut through that OSB and it dropped down to the attic, no big deal, put in your vent and you're done. Now you might have insulation there when they cut through it. So what do? Communication with the various trades to let them know what to expect and who's responsible for what. My little second picture there, you can see that vent, the insulation is nicely cut around the vent. The bat insulation there is not falling to the ground, hasn't been dislodged. It typically takes someone to go back into that attic to make sure everything looks good, particularly now that QII is more or less required. You also have your ducting and maybe some plumbing equipment or pipes up in the attic, and where in the past we would just blow in some loose insulation at the very end, now you have to consider when to put in the below deck insulation. And I don't think there's any magic bullet to answer that question other than communication between the trades. So during your takeoff meetings or kickoff meetings, make sure that gets mentioned. Costing the unknown. What we've been encouraging energy consultants and modelers to do is to, one, open up a model from a previous year and rerun it in the 2019 software to see what score you're getting and what changes need to be made. And then encouraging builders to work with their suppliers on getting cost estimates. Also, in the past 3 years, as we've been working with builders in the 2016 code and helping them overcome some of the barriers, what we would do is we would look at their project. It might be 200 homes, and we'll just take maybe 10 of those or 20 of those as a little pilot project to put in high performance attics. To get some of that learning curve out of the way. So for a lot of builders in California, they've gone through that and will be in good shape when this is in effect January 1st. For those that haven't, give us a call. We'll help you out. A few case studies from the Master Builder programs I mentioned. Here's DeYoung Properties in the Central Valley. You can see they went with the sealed attic, some advanced framing techniques, the California corner framing that allows insulation to get right up there to the corner without any air gaps. And they also used 2x6 framing. Party homes, below deck insulation here, or no, I guess this would be a sealed attic because we don't have any, what is it?
It's HVAC.
It is below deck insulation. Yeah. There we go. Great. I guess I'm not seeing the loose fill insulation above that ceiling. So I guess these photos were taken right before that was put in. But you can see everything's very nice. If you can make out, there's those cords that hold up the bat insulation. So what most builders are doing is just purchasing the regular bat insulation that you'd have in walls, but almost all the major manufacturers have products and have had them for a few years now for products specifically designed for below roof deck insulation. Something to look into. Here's a Beazer project. In this case, the ceiling hasn't been installed there, so you can look straight up. wisewarehouse.org, that's the program's official website, and it, as the name, Wise Warehouse, it is a warehouse of additional resources. We'll get this presentation posted up there in the next few weeks. There is a lot of manufacturers information on products specifically designed for meeting the code requirements, how-to guides, also additional links to other third-party resources such as CAD drawings. My contact information will be on the next slide, but there's additional contact information at wisewarehouse.org if you're interested in someone contacting you one-on-one or even setting up a meeting in your office with your team to go over more of this in detail. So I was a little worried we'd have too many slides, but I think we breezed right through. We're 30 minutes early, but let's open it up to questions. Do we have some? Matt, are you there on the line?
I am indeed, and actually there have been questions coming through, so thank you to everyone putting them through. I'm going to address some of these we resolved through the questions method in GoToMeeting directly with folks, but I'm going to air some of them verbally and our responses just so everyone's able to hear those same answers given the questions mechanism. So in no particular order. There was a slide earlier that said that we're switching from TDV to EDR in the 2019 code. That's a bit of a misnomer. TDV is still in the 2019 code the backbone of the energy calculation. TDV energy is the basis of all energy. The difference is we're switching really from compliance percent, which is just my energy versus yours as expressed in a percentage, into this new EDR framework, which is an index. And the EDR framework is an index that has two different levels. You have to hit the efficiency EDR and then the total EDR after PV. So TDV is still engaged, but EDR is the metric rather than compliance percent. So we should have been more clear on that. We also had a comment responding regarding QII and just the way that we frame it. So QII is a prescriptive requirement starting in 2019, but it is not a mandatory measure. So it's not required per se. However, the strength of the performance credit that QII gives you, so if you remove QII from a model, you're taking a fairly big performance hit, and to offset that, you need to do quite a few other measures to make up from it. It varies by climate zone and buildings. There's no rule of thumb, but it's significant and challenging to come back from. So it's good to recognize it's part of now the performance requirement, which means it is the basis to which your performance building is being compared, a prescriptive requirement. So it's the basis of the performance comparison. There was also a question regarding QII on when you're talking about the attic and you're having like a truss system, a box truss or a scissor truss or a plenum, whether or not those get treated the same as knee walls, where you need to have the knee wall QII protocol requires the sheetrock backing. My answer is I don't believe that it does, but I'm not 100% on that. And if it didn't, that to me would actually probably be a mistake within the code regulations because it's silly to put drywall there. Right? If you have a box truss into the attic, that's so you have a little bit of vertical insulation there to box out for a duct chase. But I don't have that 100%. So my gut is no, but needs to be confirmed. And if it is confirmed that the other way, that might be worth a call to the CEC. Next question. Someone talked about when you have R19 going into a 2x6 cavity, because a 2x6 cavity is technically only 5.5 inches thick, that's technically a light compression on the R19, which degrades its R value by a hair. And is that included within the calculation for the assembly U factor in the JA4 tables 4.3.1? The answer is yes, it is. They accounted for that compression element when they get to the various rates that they give you. And then the final question that came up, and others have come up since I've been talking, that I haven't looked at yet. One is about the solar mandate. And yes, the 2019 code has a solar, it's essentially a mandate. Again, this one is almost impossible to make up for with just efficiency performance. The size of it is so great, where you have an efficiency EDR you have to hit with just efficiency only, and then you have a total EDR with efficiency plus solar. In some narrow circumstances, super narrow, when you throw the kitchen sink of efficiency, beyond passive house levels and equipment qualities, maybe you could get down to the EDR without solar. But I've never seen an example of a home that actually pulled it off. So it's essentially a mandate in that regard. You can't get around it with performance. All right, and that is the answer to the questions that I received during David's presentation. I'm going to take a little pause here and look at the questions that have come in since.
Thank you, Matt. And if you have any questions that come up after, there's my contact information again. Everyone will also receive an email in about an hour after we end with a survey, and we'd love to get your feedback on that survey. There's a part in there for just free form questions as well. So feel free to type in your questions and comments in that survey that you'll receive via email in about an hour. Do we have any more questions, Matt?
I am flipping through them now. So there's a question about the battery trade-off, the new battery trade-off that's there, and removal of the PV trade-off from Rob Brooks. I'm making sure that I'm parsing your question accurately and reading it accurately. So I'll step back and think I'm doing this right. PV on its own cannot be used whatsoever to trade off against any efficiency improvements. Envelope, water heater, HVAC, you name it. PV is a separate, it only gets applied after you've hit your efficiency EDR. So PV is totally separate. The battery credit kind of straddles the two. Some portion of the battery credit can be used to offset efficiency measures as a performance trade-off. It's a small portion of the total potential battery credit, and it is scaled to the jump between the 2016 and 2019 codes of high-performance water attics and high-performance walls for that specific climate zone for that house. Actually, maybe it's not for that house, maybe for that specific climate zone. I can't remember the exact algorithm in the background, but that's it. So it's a credit that's just the 26. So you're talking about just that jump from 0.051 to 0.048 on walls in most climate zones, and that jump from R13 to R19 in the HPA-B below deck determination in certain climate zones. So it's a much smaller value that goes on the efficiency side. It is available, it's useful, and it's a good trade-off to look for if you do put in a battery. All right, and now I'm scaling through some thank yous. Yes, you will be getting copies of the slides, will be made available.
Yeah, we're going to post those to the Wise Warehouse website in the next few days. There's a lot of previous presentations there as well with similar content. So that site is constantly new materials being added to it. So check there in the next few days.
All right, and there are quite a few continuing to come through. So I'm going to do these in the order that they came and just try to be as succinct as possible. Staggered stud walls, a question from Sudhava. Yes, staggered stud walls can be modeled. Yes, they can comply with code. The modeling mechanism is odd. Basically, you model a 2x wall, whatever you're framing your stud width is in your stagger, and then you model continuous insulation to represent the gap between the stud and the next wall. Right, so the space that is, kind of gives you continuous insulation credit for that wavy line of insulation that rolls between the studs, right? You can imagine kind of deconstructing a wall from above and sort of thinking through that's a continuous layer, whereas the stud adjacent portion is a cavity layer. And that's the mechanism to do so. If that was a confusing explanation, please send me an email and I'll explain it better in another way, mchristie@trccompanies.com. So, or send one to Dave Perez, which is on the screen, and he'll get it to me, and we'll deal with that offline. There was a question about the wild urban interface requirements and these building constructions. So that is in regard to some of the requirements of roofing in a wild urban interface where there's challenges of sparks getting onto the roof and fire prevention. I don't have a full detail on that. I don't know that one top of mind enough to rattle it off. I've explored that in the past. So maybe that one we just have to take offline. But that is something that was reviewed as part of the code development process in 2016 code when these high performance attics were first introduced. So it is something that was on the mind of the CEC and the utilities and codes and standards departments, but I can't articulate cleanly exactly how that was, how that's resolved or how that's addressed. So there's a question about the solar offset. So so your solar is sized to offset the kWh use of a barely code compliant building, or a code compliant building that is mixed fuel. So it's not enough solar to cover whatever your home's kWh is. It's enough solar to cover some other home that happens to be dual fuel and happens to be the same size and happens to be in the same climate zone, but is using totally different efficiency measures. So once again, it could be possible, but man, you'd need the kitchen sink to get yourself down below, with just efficiency only. But we're not being asked at all to offset the it's not the actual kWh of the entire house, it's the kWh of, and again, you're not actually, you just have to hit that final EDR threshold. You don't have to put in that much solar. If you did extra efficiency, you can reduce the amount of solar that you put in. I don't think you can ever get to a point where you're reducing that amount of solar to zero, though. There have been some comments about builders really love their 2x4 walls. There's a lot of tradition in them. There's a lot of norms. There's a lot of ease of using 2x4. There's spatial constraints about eating to the inside of the home or eating into your easements. Builders love 2x4 walls still, and the 2x6 jump has been extremely hard. There are some other rigid foam options out there, some technology options. Phenolic foam, which is King Foam, is one of the major manufacturers that is pushing that, and they're available in California. They've been really trying to be active. I don't mean to be a sales pitch, but they are a product line that's there. They can get you in the range of R8 per inch. It's more expensive than your EPS and XPS board, but you get it, and you don't have to go to 2x6 framing necessarily, and you might still be able to hit these assemble U factors or pretty darn close to them with like 2x4 and 1.25 inches. So standard nailing pattern, standard 2x4, you just need to spend the money on the higher quality foam product on the outside rather than the money and the space on the 2x6 framing and the cavity insulation. This discussion, next question, was about how much this is applied to high-rise residential versus low-rise. This is entirely related to low-rise and low-rise only. So these are all low-rise requirements. This is the low-rise single-family residential code. In the 2019 code, they are still separate codes. In 2022, multifamily will be its own code chapter with slightly different worlds that will be kind of mashing together its current split. All those details, of course, are pending. I suggest to anyone who's interested, that casework is being done actively right now. Please get engaged with Title24stakeholders.com. And there's ways of looking in to see how that multifamily switch is developing and coming down the pipeline. Full disclosure, I am one of the case authors, as is TRC broadly. So we're deeply engaged in that. There was a question of, can battery be a trade-off for QAI? The battery trade-off, as I said before, it's targeted, or it's scaled to be relative to HP and HPW, but yes, it's a totally fungible trade-off. It can be traded off against water heating. It could be, whatever you want to call it. It's just trading off TDV energy at that point. It's just that the maximum amount of energy that can be traded off on the efficiency EDR is limited. to the relation to the high performance attics and walls changes in the code, in this code cycle. You do not fit it. Someone asked, Chris Rosemont asked about how do you fit a 6-inch R19 in a 2x4 top chord truss. That you do not do that. So I don't know where that question came from. And hopefully it wasn't implied in one of our slides that I didn't catch either, but no, an R19 bat has to go into a 2x6 cavity. There are, I guess with top chord trusses, there sometimes are, there are various ways of dangling insulation beyond the stud length itself without compressing it. So often that is done, Owens Corning has their box netting system, which they actually build out kind of a box net and then they do blown in inside there. So it's not a bat, but you are extending past the studs. Some of the other product manufacturers provide sort of little dangling tabs where your wiring that holds them up against the roof deck is extended, so you're not compressing all the way down to the stud. But that would be the key. You know, you'd have to get that if you are putting in a bat into an attic roof stud, and that bat goes beyond the framing element, you would need to adhere it and affix it there in such a way that you're not compressing it back down to the stud length, else you're not getting the same, you know, you're crushing your insulation, not getting value out of it. So there have been a few more questions about my explanation of how to model staggered stud. What you're doing is that basically the software doesn't have a way to model the full three-dimensional physics of a staggered stud wall, right? Because it's a little bit more complicated than the, you know, our 2x4+4 type of wall framing. So it's essentially a workaround that gets you to the same overall impact. As David said, the continuous insulation, it's continuous somewhere. The code doesn't really care if it's on the inside or the outside of the wall. The traditional assembly that most people build is that it's, you know, it's foam on the outside that you do stucco on, right? That's the norm, or some other kind of hardy plank or something on the outside. But in reality, you could, you know, moisture, building science, everything else coming into contingency here, you could put it on the inside layer before the gyp wall, or you could put it in a double wall, just in between the double wall when they're not even staggered, right? It's just a pure double wall, and you have this totally open gap that's continuous down the middle. The stagger stud formulation just gets complicated because, you know, it's wavy where those bridged elements are and how thick they are. But as I said, it's essentially you're modeling a continuous layer, almost as if you squished that staggered wall into a normal wall, and you took the amount that you had squished out in that application and called it a continuous layer somewhere. And the code and performance modeling doesn't care where that somewhere is. In terms of CVEC modeling, where it says inside or outside, just pick one. It's the same math. Makes no difference. You may have to explain that to your building department, though, or get someone else to help you explain it. All right. Is there a reason that sealed unvented attics weren't included as a prescriptive option? Yes, we're going back in time to 2016. There was a lot of debates on this, where sealed attics, where it was realized that a unvented attic that's not intentionally insulated is just slightly different. It's a slightly different beast. It's not the same as ducts in conditioned space, because that attic still kind of acts as a buffering zone because it's not intentionally conditioned. And it's not quite the same as an HPA, where you have this, you know, obviously not the same physics-wise, where you have this airflow and you're kind of creating this intentionally tempered attic space. As with a lot of things in the code, recognizing that most builders choose to use the performance mechanism, they decided that having another prescriptive option would just confuse it. But at the same time, they recognized that a lot of builders would be drawn towards various unvented attic or sealed attic applications. And so that is definitely a performance code option. It's one that we have found through our energy modeling and through real world testing to be, depending on exactly our levels you use, close to equivalent to the HPAB strictures that are in there. And so we often mention it with programs that we run, or information program, things like WISE that are run by the state or by the utilities. as a performance option that's a near equivalent. Dave Haggerty is reminding me that with the phenolic foam, it's R9.5 for 1.1 inches is what they're getting to right now. So thanks, Dave, for those new numbers. I hadn't looked at their spec sheets in a while. You get to see them more often than I do. So again, a great potential high density, high R value, rigid external insulation option, which can help resolve the need to go to 2x6 if you do it right. PV in a forest area, I don't remember the exact. There are allowances if your building is permanently
I believe it
by
includes
something.
Yeah, permanent structures, but I think it does include trees.
Okay, so I'd have to reread how the exceptions are written. We recommend you go to the code and read those exceptions. There are some about how that's fleshed out. Thanks, David. There's a question about the correct way to flash openings with walls. We may have some. David, do we have details on rigid insulation wall flashing anywhere?
I do not believe so, but I
would go to Building America as my first resource for that.
Yeah. The images, the graphics that I had for attics and walls, those are embedded in the Title 24 code. So that's why we use those, including the ones that show soffit vents. Going back to the fire danger, a lot of places don't build with soffit vents anymore, and you're using other venting. But the images that are in the code are what we used here.
And Bill Burke, who is very involved in kind of Title 24 work and utility work, he's mentioning that there might be some better descriptions of double walls and staggered stud walls available now in JA4 that I apparently wasn't aware of. And so there might be some resources there. Go check out JA4 and how it describes double walls and staggered walls and the modeling opportunities there. So things may have updated since the last time I investigated that aspect of the code deeply.
That's the joint appendices.
Yes, joint appendix 4.
Yeah, just do a search, CEC joint appendices, and you'll first hit there. They'll have a list of about a dozen.
Okay, I believe that answered all the questions. Melissa, did you see any that I missed?
She's shaking her head no, so I think we are good. Thank you, everyone. We had just under 100 people registered. We still have 56 people left on the call, so we're going to be wrapping up earlier than planned, but look for that email follow-up with the survey. If you have any other questions, you can put it in there. Lots of ways to get in contact with us. The WISE program does more or less sunset at the end of this year, so if you are interested in any additional involvement, let us know sooner than later. Very much appreciate your time, and hopefully we'll connect soon. Thank you. Bye.